is this being so difficult? There we go. Yes, yes. Yes. There we go. So graph. Whew. And then we're just going to integrate this from 0 to 3. So second trace, go down to number 7. Lower limit is 0. Upper limit is 3. And my integral should give me 3.59 meters. I got the wrong answer. 10 x minus 1 e to the negative 1.7 x. Boom. Try this again. I was wondering why it looked just like an absolute value function, like linear. That was weird. So I need to start using the shortcuts on the calculator. 3.59. So we should get about 3.59 meters. Okay, so that's this answer. That was that answer. And part B was 2 marks. So +1 for this answer, including units. If you didn't include units, give yourself half a point. And then +1 for this whole setup using your absolute value, limits of integration, everything. Okay, part C asks you to find when the particle is at rest. At rest means that 0 is equal to our velocity, and then we would solve for t. So we would get that 0 is equal to 10 times t minus 1 times e to the negative 1.7 t. And when I sub this into the calculator, because I don't want to do the algebra, I should get that t equals 1 second. And you can do that by, so let me delete the absolute value stuff. Now I just have my function from before in there. It. Look, there's a little intersection there. Go to second calc and then type in, go down to number 2, which is 0. And then you're going to get your cursor to the left of the x-intercept and then go to the right of the x-intercept, and you get that it's 1. And that's all you needed, just that t equals 1. You also could say, hey, this thing has to equal 0, or this thing has to equal to 0, which is what I did on my solution. This doesn't give you any 0 solutions. This does, and it's when t is equal to 1. Okay, and that was 3 total marks. So you get 1 point for knowing that you should set it equal to 0, 1 point for setting up this equation, and 1 point for your answer. That's supposed to be an A. I'm really sorry. Okay, and then this is like method. So that's the total of 3 parts. 3 and 3 is 6, 8. So this whole thing is out of 8 marks. Okay. And lastly, let's do number 3 really fast before Gemma gets up. She's not awake, but she's still late. Okay, so number 3, it says a curve is given by the function f of x equals 2 e to the x. A solid is formed by rotating the area under the curve from 0 to a, and it gives you the volume. So we're setting up an equation. This is kind of like in the around the world that we did. So we should have that pi times the integral from 0 to a of this function, 2e to the x. Oh, let me put my paper. Quantity squared, because we're doing volume, we need the pi in the square. Dx should be equal to 2 pi times e to the 6th minus 1. So then this, when I integrate it, should give me pi times 4 e to the 2x from 0 to a. E to the 6th, not 6. E to the 6th minus 1. Okay, and then you can't really use your calculator to do this algebra because we have to solve for something that's in the limit of integration. So we're going to have pi times 4 e to the 2a minus 4 because e to the 0 is 1. 2 pi. So now we have an equation where we have e to something and we have like a number out here. There's a 4 in both of these, so I can pull that 4 out front. So I should get that 4 pi times e to the 2a minus 1 is equal to 2 pi e to the 6 minus 1. So now I can cancel out my pi's. This is really 2 e to the 6 minus 1. And then let's see, 2 e to the 2a minus 2. I don't think I did this much work when I did it before. E to the 6 minus 1. I feel like there's something wrong. I feel like that 2 should have gone away. Or maybe I did it wrong the first time. And she's talking. And yeah, somehow before I got 2 pi as my coefficient. I see why, I think. Because I didn't use the chain rule when I integrated. This should be 2. Because it would be 4. I differentiated instead of integrating. God, so embarrassing. So when you integrate, you divide by the new power. So I should have taken, yes, this does become 4e to the 2x. But when I integrate that, I have to divide by 2. And so my 4 should go down to 2 instead. So basically, let's see here. 2. These both just like totally cancel out. And so you end up with just basically almost the same thing on either side. So you can cancel out your negative ones. And really the only difference between these two is that one has 2a and one has 6. So we can say that 2a has to be equal to 6 in order for those two things to be equal. When we divide by 2 on both sides, we should get the a is 3. And that should be your final answer. Okay, now you would get 1 method mark for setting up the integral of pi times your function squared. You get +1 for your bounds. You get +1 for setting it equal to the given volume. Let's see, you get 1 for actually integrating, or 2 for integrating correctly, which I would not have gotten if I did this by myself. And then +1 for like recognizing that this is the function 4e to the 2x. So for like getting that answer, for actually squaring it correctly, which is what I was thinking, which is why I did it wrong. +1 for this final answer. Sorry that I'm skipping all over the place. And +1 for the solving. So +1 method for solving that whole thing, doing all that algebra. And that should give you 1, 2, 3, 4, 5, 6, 7, 8 marks. So out of 8 total marks. Okay, so that is section A of paper 2. In the next video, we'll do section B of paper 2. That one will probably be done later tonight because I have to go get this toddler out of bed. All right, have a great day. I'll see you guys later.